Well, hello YouTube. What we got here is a mock-up, a proof of concept of a star delta starter system. What we have here are 3 contactors and a SSR, a solid state relay that will control the delta time. I have a couple of light bulbs to show the operation here. There's no actual line voltage going through the setup right now. What this is basically a mock-up. This is what the inside of the motor would look like with the terminal block on a 6-wire delta motor, or it can also be wired in the Y direction. So we're going to give a little demonstration here. Okay, we're going to start up in the Y or star, and we're going to activate the delta circuit, which is on a timer. It shuts off the Y because it's interlocked with the delta, and vice versa, so neither one of the contactors could be pulled in inadvertently. The main contactor, stays in at all times. We're using an overload contactor, which is active. It will cycle through the Y, goes to delta. So that is the timer feature on this. Since I'm going to be using this setup for both star motors and delta motors, I keep in the option to just run it on star, and it will not go into delta, and we retain the overload. This particular setup here is capable of handling 10 horsepower the way that it is, and if you want to run bigger, you got to use bigger components, but half of the load is taken by any contactor that's in series with the main contactor. Okay, we're going to take a look here at the control system. I'm going to go ahead and disconnect this. I got the box open here for easy viewing. What I'm using is 2 momentary switches and a single maintain contact switch. We're having a total of 4 wires running into the box for control. Since I have this mocked up with 120 volt contactors, I'm just using 120 volts right out of the outlet to power this thing up as a proof of concept. When I actually put it in production, I'll probably put a control transformer on there so I can run 220 volts through it, so I don't have to change anything. This can be set up also with 220 volt coils on your contactors, and you can use the line voltage in order to operate the system here. Basically, what's going on inside of the box here is we have power that comes in from one leg of the source. It would be a transformer usually that powers up the whole system, comes through here, goes through a normally closed switch. On the back side of this normally closed, I'm giving power to the 13 post on the normally open side of this auxiliary contact, the contactor. We have a normally open push button switch, which gets the power from our normally closed switch. When I activate the main contactor, the main contactor pulls in, as a secondary action, the Y contactor will pull in at the same time as the main contactor as a default. We have to switch in power in order to make the timer operate. That is where we're going to get our white wire here. The white wire's on the back side of this maintain contact switch. It powers up the timer. When the switch is in the off position, no power goes to the timer. It will not go into Delta without the timer. Last but not least, we have the brown wire. Oh, excuse me, that's where we started off. We have the brown wire, which fed the holding circuit. It all fits into this neat little box here, believe it or not. And pretty soon we'll get this over to the shop where I can actually run a motor. I don't have the capability here at the house, but I made this mock-up, and basically it'll go inside of an enclosure. This is just mounted to a spare piece of plexiglass that I had laying around. It was easy to mount it to and all that good stuff, and hopefully you guys will get some value out of this. There will be a follow-up video to explain how it actually works in real life and all that, but this is the proof of concept. Thanks for watching.